In this problem we're going to be going through how to find roots of equations. Also go through another one where we're going to be solving, use solve blocks to find the solution to equations. This homework here is at the course website. If you just come to APMonitor.com, courses, and then select Introduction to Programming. Let me go and make this just a little bit bigger here. There's some additional information on solving equations here at this page. There's a couple tips and sheets to show you how to solve these. And then if you come back up to the top, over here on the right is the homework, and then scroll down to symbolic manipulation, plots, and solve blocks. I already did solutions 1 through 6. We're going to start with 7. Okay, so I'll make this just a little bit bigger and then scroll down to 7. Okay, so it says find all the roots of the following equations with the most efficient MathCAD procedure possible. Okay, so the first one, I'm just going to put everything onto the left-hand side of the equation. Okay, minus 2, I'll put control equals there, equals 0, just to show that kind of like as a comment. And then in order to solve this, I'm going to use the polyroots. I'm going to do control M there to insert a matrix, or you can do it from the toolbar up at the top. Okay, and then I'm going to put in -2, 0, and 1, and those would be just the -2, 0, and 1 that are in front of that. Okay, so this is a polynomial, and if I do polyroots v, then it shows me the roots of that. Okay, so let's go on down to the next one, which is going to be something that's going to be a little bit, just in a polynomial form. So what we're going to do is just define a function, f of x, and that's going to be e to the x plus natural log of x minus 10. Okay, so that's our, and then we have a guess value as well. And now this is going to determine which root we're going to find if there are multiple. And then I just use the root. Okay, so I can't use polyroots because I don't have a polynomial there. And I'll put in the guess value and xg. Okay, and that will come up with one of my roots. Okay, so if you change the guess value and have multiple, then you might be able to come up with the other one. Let's go and try that just on this first one here, f of x. Okay, I'm just going to copy, well, I'll just put that in there, x squared minus 2. Okay, so if I used root f of x, I'll do a guess there. And it's going to give me an error because I don't have, well, it should have given me an error. Guess, I'll say 1. And then when I evaluate this, I'll come up with, this higher root. If I put in -1, then it's going to find this lower root. Okay, so depending on where you give it the guess value, you might find one or the other of these solutions if they're multiple. Okay, go ahead and do that for the other ones. Just go ahead and fit in, f of x equals that function, and then find the roots. And the second one is going to be between -5 and 5. Okay, so you just got to use different guess values until you find the solutions for part C. There are going to be 4 different. Well, I'm going to go ahead and just do that. 4 different roots to that. Okay, so x squared plus, and then do p, control G, that makes it pi, equals, oops, let me go ahead and just do, instead of equals, I'll do minus tangent of x. Okay, and then if I do x guess, and also that's a -4.75, and then let me use the root function. Okay, so there it is. Let me go ahead and just create a couple copies of this. Okay, and then if I just make a couple copies, and there's the green there that says I've redefined this. And that's okay. I'm just doing, reusing those variable names. I just have a hard time aligning these up. If you do, then you can always use this, this align function right there. Okay, so I'll just click no. Okay, so you can come up with different guess values here. So for example, negative 4.75, I'm going to do negative 2. And then you could also do something like 1.3, and I'll do 4.75. Okay, that still came up with a negative there. You might need to find, a better starting point. Okay, and one of the ways to do that is just go ahead and plot this. I'm going to go ahead and put in a plot right here, and let's do x versus f of x. Okay, so you can see, what this this function looks like. That's mostly due to that, the spikes are mostly due to the tangent function, and you want to find where it equals 0. Okay, so you can plot it, and then if you just drew a line straight through here, you want to find all of those roots where this function is going to be equal to 0. So those are 4 of the roots right there, and this can help you find where those roots are. Okay, so just go and do the other ones on your own. I'm going to go down to 8. So we want to find a solution to the following equations using solve blocks. If there's no solution, determine the values of the unknown that result in the least error in the equations. You will use the min error instead of the find. Okay, so remember the if function, that's going to be in part C. Alright, so let's do, let's see, so the first thing that we want to do for a given block, okay, or I guess it's a given find, is we're going to have some guess values. I'll do x guess is going to be 1, and then y guess is going to be equal to -1. Okay, so I'll give it some guess values there, and then I want to do a given. Okay, don't hit space. If you hit space, it turns it into text. You want this as kind of like a variable there. Okay, so still in Times New Roman, when you hit space, it turns it to Arial, and that so you have to have it as just type given and then enter or space down from there. Okay, now we're going to go ahead and put in our equations here. Plus y squared equals, okay, so to do the bold equals, do control equals, okay, and then 1, and then the next equation is going to be x guess plus y guess equals 1, okay, and then below that, what we can do is now get our answer, and that's going to be equal to find, and we're going to find the solution based on these guess values. Okay, so answer, so it found the solution, the x and y values that gave us, that satisfied these two equations. The other way I can do this is just type Control M, do a 2 by 1, and maybe x and y there instead, and then I could say x equals 1 and y equals that number. So if you don't want to return it as a vector, you want to put it back into individual variables. You can put on the left hand side of that, you can say this vector equals find, and then it'll put them in there for x and y values. Okay, so there is we've got so let's go on to the next one now. Actually this one is going to have 2 solutions, so depending on where I start, I could also get a second solution. Okay, so there's another answer. Okay, so the one is the unit circle, and then the other equation is just a line. So there's going to be 2 places where that line intersects the circle. Okay, so again, it's sensitive to the initial guess values. Okay, let's go on to part B now. This one is going to be, similar. I'm going to have some x, an x guess value, okay, and then a y guess value. I'm just going to change these to x and y. I don't want to use the g there. Okay. Y equals -5. Let's go ahead and just put our given statement there, and then our x squared plus, let me get this right, x squared plus, okay, sine of x equals y times cosine of x. Okay, there's our first equation. Now our second equation is going to be y equals x squared minus 1. Okay, so there are the two equations. And then if I do another vector here, a 2 by 1, and I set that equal to, okay, now in this case, if I do a find, and I do x comma y, oops, I did a 2 by 1 there. I want x and y that are returned. It is x equals -1 and y equals -5. I'll do a solution here. Okay, solution. I have. Okay, so it didn't change the answer here. From the original guess values, and so what we might need to do is instead use min error instead. Actually, let me do this, check and see if it. Okay, variable undefined. So it wasn't able to. Let me see if I can reprocess this one. Okay, I'm going to save it. And something is not quite working right. Sometimes this happens in MathCAD, where it seems like things just stop updating. Okay, so what I'm going to do is, one of the techniques is just save it, okay, and close it, and then open it back again, and see if that takes care of the problem. Okay, so I closed it, opened my sheet again, and let me just go ahead and scroll down here. Something is just going a little bit slow right now. So let me see if this is going to work. It's trying to update this graph. Let's see, it did find the roots of those. Okay. Let's see if I can delete this. Oh, no, there it goes. Okay, so it came up with, okay, so let me come down here and see what's happening. Okay, I'm going to do answer instead. There's something going on with that. Okay, so it didn't find an answer there. Oh, you know what? I put the control equals there. That's why this was not working. Okay, so it said this variable is undefined. It couldn't find that. So we might need to do min error instead. Okay, and if I hit equal, then it's going to minimize the error. There was no solution to this, and so it we did the best we could in terms of finding an answer. Okay, let me put those x and y back in there. Just okay, so Control M, X and Y. Okay, so then if I do X and Y, okay, so we can figure out how much this is not satisfied. Just, you can check it down here. Go ahead and just evaluate this minus. Okay, let me see if I can get this working now. Minus that. Okay, so how much it was not satisfied. Okay, so it was off by 0.105 on that one. And then this one is off by, let me put that back in there. Okay, copy and paste. And then if I select this, okay, and just type okay, so this one, if I hit equals now, then it says that I was off by 0.06. Okay, so it couldn't satisfy that, but it did the best it could, and we used min-error to try to come up with the best answer possible, even though we couldn't satisfy those exactly. Okay, so let's go on to the next one. We have an if statement here. You know, and I can define this function. Okay, so let me go ahead and just do Control Enter, just start a new page right here. Okay, so just for printing purposes, or just separate the sheet. Okay, so I have f of x, and I'll set that equal to if, and then I'll do x is less than 1. We'll do x squared plus 2 times x minus 1. Okay, else it's going to be, let's come up over here and close these. Okay, so let's find the it's a calculator, there it is. Okay, so the nth root, and we want to do x to the 1/3, okay, plus log of x, okay, plus 2. All right, so we have f of x there. So if I did f of, let's say 0, okay, that's going to be equal to -1. It's going to use that first expression there. But as soon as I go to like 2, then it's going to use that second expression. If I plot this, okay, f of x versus x. Okay, let me come up with a couple x values here. I'll say that I want to go between -1, comma, -0.9, and then semicolon, all the way up to 5, for example. I'm going to see this kind of switch over from one function to the other. Okay, so what we want to do is we want to solve this, you know, find out where this equals 0. So you can see right there, you could kind of graphically pick it out, but let's go ahead and solve this with the find, you know, in the given block. Okay, so we're going to do given, and then I'm just going to take this equation right here. Okay, I can take that equation, set that equal to 0. The other thing I can do is just say given is f of x is equal to 0. Okay, because I've already defined that up above as a function, and then I could say x equals find x. Okay, so let me give it a guess value as well. I just need one guess value. I'll say 2, and then x equals 0.414. Okay, so in this case I defined x here. I had to give it a guess value. Don't forget that. I just set use the control equals. I had already defined my f of x right up here, and then I did a find, and then just displayed the answer. Okay, so that's it for 8. Let's go on to 9. So this one's just a little bit more, just a little bit more complex. And what I'll do is just let's come down here, create a little bit of space in our sheet. Okay, and we'll do problem 9. Okay. Okay, so this one is an incompressible fluid flows through a constant diameter straight horizontal pipe from point 1 to point 2. It's described by this equation. where P sub I is the pressure at point I, rho is the density of the fluid, L is the length of the pipe length, D is the pipe diameter, V, AV is the average velocity along the section of pipe from point 1 to point 2, and F is the friction factor. So the friction factor can be determined from the Colebrook formula, which you see there with the Reynolds number, and epsilon is a value describing the roughness of the pipe. So then we give you some information about the setup and the fluid. Okay, and then we'll have two equations and two unknowns, and we'll use a solver. So remember that F and V average have different units as well. Okay, so let's just go ahead and first of all start with some of the data that's in our problem. Okay, the density is 994 kilograms per meter cubed. All right, mu, just type M, control G. That's 0.000, 3 zeros there after the decimal point, 87645, and then that's going to be pascals times seconds. Okay, so that's viscosity. Do E, control G, that's going to give us an epsilon. Okay, and that's going to be 1.524 times 10 to the minus 3. And that's a roughness, that's in millimeters. Okay, and then D is our diameter, and 1.91 times centimeter. Okay, so that's the diameter of the pipe. We also have delta P. I'm going to do a capital D and then control G to get a delta. And then P equals negative 70 times kilopascals. Okay, that's the pressure drop. The length is going to be 20 meters. And then our guess velocity is going to be 2 meters per second. So this velocity is going to be dependent on a couple things. We also have a friction factor guess, and I'll say that's 0.001 based on the kind of the order of magnitude that we would typically expect from a friction factor. Okay, so that would give us a good guess. Now the next thing I want to do is just do my given block. Okay, and then go ahead and put in some of my equations. Now I'm just going to have two equations, the ones that are shown right up there. Okay, delta P over rho. Okay, equals negative F. I'll put my guess value in there, L divided by D, times the guess value for the velocity, and divided by 2. Okay, so here's the first equation. The second one is 1 divided by square root is the backslash. Okay, or you can find it up here in the calculator. Okay, FG. Okay, that's my friction factor. And control equals negative 2.0 times the log. Okay, and then what goes in here is epsilon divided by D divided by 3.7 plus 2.51. Okay, now everything else is going to go here in the denominator. D times V sub G divided by mu. Okay, hit spacebar a couple times, and then hit your backslash again. FG. Okay, so we have our two equations right here, and then what I want to do is go ahead and get the solution to V and F, the velocity and the friction factor, and do the colon there instead of the control equal like I did last time. Okay, and then do find with capital F there and FG. Okay, so I found a solution, and my velocity and my friction factor are right there. Now if I try to display these in one vector like that, it says that the units don't really match. We just have to display them separately because they have different units. Okay, so this is the velocity and then also the friction factor. If I change this, okay, let's just see how sensitive this is. It still found a solution. If I had a friction factor of 0.1, it still found a solution. Let's try up to 1. Wow, okay, so it still found an answer. Even if you had put in 1 and 1, it was still able to find an answer. Okay, so that concludes this. Here's this number 9 here. That was the end of this. Okay, so if I just come back through here, 7, we were just finding the roots. You can either use root or polyroot. If you have a polynomial like you do in D, just use polyroot. For B, C, and E, you'd have to use root. Maybe plot it and look for where the roots might be close to, and then adjust your guess values to get close to those. Problem 8, we introduced the given block, these solve blocks that have the given and then find keywords or functions. We can also use the min error. I showed you how to use an if function as well. And then this last one, we did an engineering problem where it's a fluid flow through a pipe, 2 equations, 2 unknowns. Just a little bit complex, but not too bad.